Greetings viewers. This first video deals with the computer-aided design of the printed circuit board. The design used in a demonstration is a simple power supply circuit, however the technique can be applied equally well to more complex projects. I am using the Vutrax PCB CAD software because it's the one I have most experience with. There are paid and free versions available, but it's important to know it's not the best program for beginners because being complex and powerful does not make it easy to learn or especially intuitive. Most projects start with adding a few new component symbols and footprints to the library before starting work on the schematic. There will be subtle differences, but most PCB CAD software will follow the same basic design principles. So here are the schematic symbol and PCB footprint for a new bridge rectifier I need on this project. Although there are several ways of doing this, the most straightforward is to physically draw the symbol and the schematic footprint and then assign numbers to the pads and connection points. The software can then automatically, with prompts from the user, create the association between the two elements and use them correctly. Once all the library parts for the project have been created, it's time to draw the schematic on which the printed circuit board will be based. As you can see, the schematic is already drawn, but here's a quick demo of how to retrieve schematic symbols from the background library and then connect them together in the schematic. Once the schematic is complete, the software then analyses the schematic to create the connection file, which is inputted to the next stage. The next task is to create what is known as the rat's nest, which is a physical representation of the component footprints and the connections between the paths, as described by the schematic. To do this, you populate the option boxes with the source files that will be required. The software then generates a random layout. As it does so, it creates an error list which you can look at to examine any issues. Then it displays the rat's nest. First of all, I import a case outline and board profile on which to work. These have been drawn previously in a separate file. Now starts the most complex and difficult part of the task. There is really no way around it. You have to position the components for the simplest connectivity by trial and error, while maintaining awareness of any physical constraints you might have on the placement of components. These might be thermal, physical or electrical. While it can be challenging, it's also the most enjoyable part of the process as well. Work progresses slowly as you get the components and their layout sorted out. You can get the software to modify the order that the components are connected if it doesn't suit the layout you've decided is best. Looking at just the tracking layer, you can see now that everything is laid out such that it can be routed fairly easily. Now's the time to firm up the routing, changing track widths and pad sizes and adding that final polish. Once that's complete, the silkscreen identification can be adjusted so all the component names are visible when the board is populated with components. And when you're ready to make your first prototype, you can plot or print out all of the layers here: copper tracking, solder resist, and silkscreen identification. Please let me know in the comments section if you enjoyed this video and you would like me to clarify any aspect of this process. Be sure to check out the second video, which deals with the construction of a prototype through-hole printed circuit board that can be made economically at home. Thanks for watching. Bye now.